Graphs involving sine or cosine can become quite complicated when you add in horizontal transformations. But based on ideas we've already discussed in class, this video shows a process you can use to simplify things a bit. And that process is based upon knowing what we call the feel of each graph. What does one period of each graph look like? We have learned that cosine starts at a high point, at a relative maximum. If we then go one full period later, whatever the length of that period is, if we go one period later, we've got to be at that relative maximum again. If we then go halfway through the period, we've got to be at a relative minimum. And if we then go a quarter of the way through the period, in other words, halfway between a relative max and a min, we have to be at the midline of that graph, or what we call a midpoint. And so we've learned that the graph of cosine, one period of the graph of cosine looks like this. Everything there is based upon one full period, as well as a half of a period, and one quarter of a period. For sine, we know that the graph starts at its midpoint, actually, at its midline, and going one full period later, I hit that midline again. Halfway through the period, I am again at that midline. A quarter of the way through the period, I'm at the relative maximum and the relative minimum. And so this is what we've memorized as the feel for one period of sine. Both of these are based on what we're calling the starting point for the graph, and that's going to become important when we discuss shifting these graphs left or right. One other thing that I want to point out here that is critical to shaping up these graphs is that idea we've discussed about how if you start at any midpoint and you go 1/3 of the way in the x direction towards a relative max or a relative minimum, then you need to go 1/2 of the way in the y direction towards that relative max or a min. And that's true for both graphs. It doesn't matter where I'm at. If I take a midpoint and go 1/3 of the way in the x direction, then to shape up the graph nicely, I go 1/2 the way in the y direction. So starting from there, what that means is that we're going to need some kind of mark on our x-axis that will allow us to mark out each of those quarter periods here, but also to mark out these 1/3 of a quarter period. So a good scale to use is going to be 1/3 of 1/4, or in other words, 1/12 of the period. Now remember that the period of a sinusoidal graph means either sine or cosine, but the period of that graph normally is 2 pi. So with the stretch or compression that would be caused by a coefficient inside of the function, the new period is going to be 2 pi divided by that coefficient. As an example, let's find the period, and then a useful scale for graphing. F of x is equal to 5 sine of the quantity 3x minus pi halves, all minus 2. Remember that period is symbolized with a capital T. So what I'm going to do is I'm going to take the normal period of sine and I'm going to divide it by that coefficient on the inside with x, and I get that the period of this graph is going to be 2 pi thirds. Period used to be 2 pi for sine, but that 3 is compressing it, and so now the period, the length of time it takes to complete one cycle, is only 2 pi thirds. Based on that, then, I'm going to calculate a scale that might be very useful on the x-axis. I don't have a symbol for that, but I take that new period and I do 1/12 of it. That means, of course, to multiply by 1/12. Beautiful thing about fractions, they cross cancel, and I get that a useful scale for this graph is pi 18ths, which we will see how that plays out in just a little bit. I would like to point out that this method I'm showing you about creating that scale only works if the scale is also a factor of the phase shift. Phase shift is a fancy word for the shift left to right. If that scale is not a factor of the phase shift, the problem's more complicated, but we're not looking at those right now. Also, if you were to look at a different textbook or work with a different teacher, look at something online, they have different ways of presenting what is called the general form for a sinusoidal function. For this class, in order to match what we've already done with transformations of other functions, we're going to use the form f of x is equal to a times sine of b times the quantity x plus c, all plus d. By the way, a sinusoidal graph means either a sine graph or a cosine graph. And so this is the form we're going to use just because it fits with what we've already talked about as far as transformations. So let's get into an actual example. We will come back here now and look at that function from before. F of x is equal to 5 times sine of the quantity 3x minus pi halves, all minus 2. The first thing we need to do is to put that into our general form, which involves factoring out that coefficient. Can't pull it out of the sine function, but I can factor it away from the x. Remember that factor out really means divide by. So 3x divided by 3 leaves me with x, and pi halves divided by 3 leaves me with pi 6. And so this becomes my general form. In this form, I have a whole lot of information that I can see very easily. First of all, this right here tells me my midline. Remember that the middle of the graph is only affected by the shift up or down. This number right here tells me what's called the amplitude of the graph, or in other words, how far above or below that midline the relative extrema are going to be. And now this piece right here tells me about the phase shift, or in other words, the shift left or right. We now know that that phase shift is going to be pi 6 to the right. And finally, I've got this coefficient right here, which is going to talk to me about the period and the scale. We already did this, so I'm just going to write this down in order to make the example complete. The period for this graph is 2 pi thirds, and the scale that we should use on our x-axis, 1/12 of that period, turns out to be pi 18ths. So let's begin with that and start setting up our axes. So in the x direction, you need to choose a tiny little mark and let that represent your scale of pi 18ths. And the reason it needs to be small is because once you get that set up, you have to be able to draw at least 12 of those marks. Remember that the pi 18ths is 1/12 of the period. So it's important that we can get at least 12 marks to show a complete period for our graph. In fact, we're really going to need to go more than that. Eventually, I'm going to request that you draw at least 2 periods. But for right now, we're just going to make sure that we can get a good amount in there. We also have the shift that we're going to have to deal with, so make sure you can get quite a number of those marks in there. In the y direction, we know that we need to go 5 above a midline of -2, which is going to put me at +3. We need to go 5 below -2, which is -7. So I just want to make sure that I can get 7 equally spaced marks in the negative y direction, 1, 2, 3, 4, 5, 6, 7, and that I can get 3 of those marks marked off in the y direction. So there's +3. It might also be helpful to put just a few more marks on the x-axis. Remember that each mark is pi 18th, so if I count out, say, 6 of them, 1, 2, 3, 4, 5, 6, I have 6/18ths, which we know reduces to pi thirds. So every 6 marks is pi thirds. Counting out a number, another 6 marks then gives me 2 pi thirds, etc. Okay, so that'll just help later when we're trying to figure out some of our points. Over here, 1, 2, 3, 4, 5, 6. Here's negative pi thirds. Now that I have my axes set up, I'm ready to start graphing. As before, we know that the first thing that we want to get set there is our midline. Remember to do that with just a very light dashing. It's not actually part of the graph. It's not an asymptote, so we don't want it with dashes. Just a little dotted line just to set it as a reference. And from there then, we are going to set our starting point. All of this is based on looking at the starting point for the graph, which on sine we know is the midpoint. However, that midpoint has been shifted pi 6 to the right. So I come in here and I'm ready to set my midpoint, but I need to move it pi 6th. If I think about the fact that each mark is pi 18ths, pi 6 is actually 3/18ths. So I move 3 marks over and set my first point, my starting point. Now, pretty much the whole graph is over because everything is about using that quarter of a period and the third of a quarter, in other words, using the twelfths. We know that one period is 12 marks, so if I now count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 marks, I again am at my midpoint. That is one full period for the sine graph. We know that halfway through that, or in other words, 1, 2, 3, 4, 5, 6 marks, we are again at the midline. And halfway between those, in other words, 1, 2, 3 marks, I've got to be at my high point. And my high point was 5 units above the midline. 5 above -2 is 3. And then halfway between these two midpoints, I got to be at my relative minimum. 1, 2, 3 marks is what a quarter of a period is. I got to be 5 units below the midline, so at -7. And finally, I need to set up those 1/3, 1/4. But the nice thing is, here, or 1/3, 1/2 marks. Here is a quarter of a period, so 1/3 of the way corresponds to that mark that I've set up as my scale. And that was the beauty of this, is that I actually have a mark for that 1/3 in the x direction. Now then I also need to go 1/2 in the y direction. Half of that amplitude is 5/2 or 2.5. Going 2.5 units above the midline sets me at this point right here with a y coordinate of 1/2. And I can just repeat that over and over again. Go 1 mark, or in other words 1/3 of the way in the x direction, go up halfway in the y direction, or 2.5 units. From a midline, go over 1 mark and go down 2.5 units in the y direction. I can just do that over and over again, and that is going to give me a lot of non-baby points to help me shape up this graph. That whole 1/12 thing was so that we could have a nice, easy way to mark out the 1/3, 1/2 non-baby points. And at this point then, I am actually ready to try to draw the graph. That right there is mostly acceptable. Remember, it's very difficult for me to graph here on the whiteboard. But you get something basically like this. Remember, you really should try to finish a graph. Ooh, my eraser was a little big. You really need to try to finish a graph either right after a relative extrema or in a midpoint. So now I got to go in and try to figure out some of my points. Remember, you always need to label 5 points, relative maximum, relative minimum, a midpoint, and some of those non-baby points. I'm going to pick a non-baby point right here. And I can simply count if I want to. 1, 2, 3, 4, 5, 6, 7, 8. 8/18ths, which is going to reduce to 4 pi ninths. And we know that it was 2.5 units above -2, or in other words, 1/2. Don't forget, of course, that you want to be checking things on your graphing calculator. I have the function graphed here. I've set my window a little bit. I push trace. I type in my 4 pi ninths, and I see that, in fact, the y coordinate is 1/2. Make sure you check a few of the points. So now what I have for you is sort of a list of how to go through graphing these functions from the feel. You can, of course, copy that down. Be sure to check yourself numerically. And then here's that list for how to graph these transformations of trig functions.